Claire? 6,156 centimeters squared, 7,142. Ava Ritkers. Number 1 was 2/65. Alex?
What was number
15? 2.4? Is that yours, Caitlin? 16. 3/2. How many people missed 0? Love it. If you didn't miss any, then you probably aren't learning anything with math. However, if you missed most of them, you might have some learning to do. Shall I? Number 4 is on the table. Children, number 4. See if we can't make some heads or tails out of this. Now, unfortunately, boys and girls and ladies and gentlemen, when it comes to the problem like number 4, the wording is so important, and that's where most people go wrong. Again, you're kind of thinking scale factors, but probably for this, for right now, the best thing to do is to draw that thing out. All right, where we at? Shell hammer. Again, your computer screen can be a square, so that's what I would use. And what dimensions would you use for your unfair square? I'd use 10 because that's what percentages are in hundreds. Now, if 10 is increased by 50%, what would its new dimensions be? Increased by 50%. An image is increased by 50%. What's my new dimensions going to be, Alex?
15 by 15.
Yeah, my new one's going to be 15 by 15. So we can agree. We know the areas of these things. They're pretty easy to figure out. The area of this is 100. The area of this is 225. Now, the question is, how am I answering this? Its area increases by what percent? And you might just as well draw yourself a little percentage box here. Because we know the original area, we can figure out how much it increased, and we know the final area. The original area is right here. It started out being 100, correct? It ended up being 225, correct? Which is an increase of what? 125. And the beauty is when you picked that 10 by 10 square to start off with, the original percentage is always 100. Kind of weird. All of these numbers will actually match what you got because we started off with a 10 by 10. So really, this hopefully was the answer that was in the book. It's 125%. That's how much it increased. Is that what the answer was? Okay. Now, you could shorten that process by saying, what was the scale factor? To go from 10 to 15, what is my scale factor? 1.5. And guess what 1.5 squared is because we're talking area? Well, it's I can't. I'm not going to go there. It is 225, but it started out, if you have to subtract the 100 you started with, that's where 125 comes from. I would draw the box and be done with it. Which means you should ask me, is that going to be the same way the problem is going to be? Somebody should ask me a clever question like that. To which I can tell you I don't know because I don't have it in front of me. Sorry, but I could find it. MD? Number 2. Alex figured she saved $12 buying the item at 30% discount. How much did she pay for the item? Again, best way to do this, draw your box. Fill in the blanks. It's a discount, so you have your original price, correct? Minus the discount equals your final price. And the original is always 100%. I don't know if I know any of the other stuff. Oh, I do know the discount. The discount is 30%. So the final percent was 70%. I know all my percentages. Now the question is, saving $12. Which of those, is that the original price was $12? Was that how much her discount was? Or was that what the final price she paid was? Saving $12, which category would that fit? Stupford?
The discount.
Yeah, that's how much she saved, that's how much she gets off, $12. And then, how much did she pay for the item? That would be the final price. So that's what you're looking for. You just make those fractions out there. 30 over 70 equals 12 over what number? Easiest way to do that, Madison? Well, there's an easier way to multiply. First thing I would do is reduce that, cut off those ending zeros, and then 3 times what is 12? 4. So 7 times 4 is 28. That hopefully was the answer. $28. So much of this is confusing because of the wording. Alex,
How do you get number 1?
how do I do it? A deck of 26 alphabet cards contains only one card for every letter, including the vowels A, E, I, O, U. In Spanish, one card is drawn and not replaced, then a second card is drawn. What's the probability that both cards are vowels? So, this is the way I would write it out. You want the probability of a vowel, and then a vowel, and you have to say it is not replaced. That's key. Okay? Not for the first draw, because in the first draw, how many vowels are there? 1, 2, 3, 4, 5. How many letters? 26. But the thing is, you pulled out a vowel and didn't put it back in. There is now no longer 26 cards in there. There's now only 25 cards. And you pulled the vowel out, so now there's only 4 left. Okay? If it would have been with replacement and they put it back, this would have been exactly the same. But since they didn't put the card in, it changes your probability for the second draw. Your probability of both of those happening is what you get when you multiply those. I would do some cross-canceling first. 5 goes into 5 once, into 25 5 times. Cut these both in half. And that's where 2 times 1 is 2. 13 times 5 is 65. We have a 2 over 65 chance. And again, the key there was the card was not replaced. Not by the way, correct me, it's off today. Everybody got that. Okay, Bron. Who? Wow. You're just going like on the left side of this page. I like it. Did you do that just because I already put stuff where 3 should go? What does 3 say? Which of the following is not a characteristic of graph displaying direct variation? To this, I would say in my notes, direct variation is, I'm not even going to look at the problem, but I'm going to say direct variation is same thing as being proportional. And for things to be proportional, 2 things have to happen. Number 1, they have to, Maggie? Okay, go through the origin, which means when 1 is 0, the other one has to be 0. And the other thing, it has to have a straight line, which means it has to be a, what we call that constant of variation. There has to be a constant factor. I can't remember what we called it. So before I look at those, I'm going to look and make sure those are true. The graph is aligned or aligned points. Yes, that has to be true for it to be direct variation. The graph aligns with the origin. That's true. The slope of the line is positive. Gosh, did we have to do that? The graph of the line is in the 2nd and 4th quadrants. Let's see here. Graph aligns, the slope of the graph is positive. Does that have to be true? Why would letter C have to be true? Because remember in direct variation what we said? In direct variation, we said it always says one goes up, the other one has to go up. Okay, well that means it has to be positive slope. Okay, why does it have to be slope? Because that's the way if one goes up, the other one goes up. If one goes up and the other one goes down, Okay, that's when you get that negative slope sort of thing. So this has to be true. Which one of the following is not? Second and fourth quadrants are here. And that would give you something with a negative slope. Would be the same thing as saying that. So the letter D, I hope, was the answer, correct? You will always see direct variation slash that always going from origin in some sort of a line like this. That's kind of a tough one. What lesson did that come from? What's that saying there?
16.
That's a 60 what?
9.
69? Maybe it was something that hit very hard. Okay, Michelle Hammer.
Are you using a pen?
Is that on this page or do next? Next?
Yeah.
Oh, do we have a cylinder somewhere? Is it on this page? Now, here's the deal. Lateral surface area. What is lateral surface area?
Area of the base.
Nope. Actually, it's everything but that. Lander?
Remember the base times height.
Yes, sure. Perimeter of base times the height. It's the area of the sides, not the bases. Area of sides, not the bases. And the formula for the lateral surface area of a cylinder, LSA of a cylinder, okay, would be, how do I find the perimeter of a circle? We call that the circumference, which is pi times diameter, and then that would be times the height. So if you're finding the lateral surface area of this, it would be 3.14 times its diameter, which is 20, times its height, which is 10. And that's where, somebody said 200 pi, that would be true, but it didn't say to leave in terms of pi, so probably if you came up to me and complained enough about it, I would probably give you the pi thing. I don't know. Volume of a cylinder, that's the area of the base times the height, so that was pi times radius, that's the base area of the circle times the height. So again, that would be 3.14 times, what's the radius? 10 times 10 times 10. So 1,000 times that, 3140. This is inches cubed and that's inches squared. Might as well knock off those two birds all at once. Is tomorrow got a cylinder on it? I don't know. Not 100% you'll be taking this tomorrow or Thursday. All depends on if there's art. And art depends on Stupford? If everybody's there. Why? Because Mrs. Stone does not want to set all this stuff up and then have to re-explain. Why? Wow, you caught up. Okay, Matt. I would love to do 15. Didn't you ask me about this one, Cameron? You did? Apparently I wasn't very good in explaining it. X minus 0.5x equals 1.2. When you solve equations, what's the first thing you're supposed to look to see if you can do? Anybody? Of course. Yeah, can you simplify on either side of the equal sign? Well, you can't do anything with 1.2 because it's only one number, but can I put these two together? They are like terms. If I have 1x and I put 0.5x with it, $1 plus 50 cents is 1.5x. And then how do you solve from there? You're going to have to divide it out. And remember, since the whole problem is in decimals, that's just how they want their answer. So you divide 1.5 into 1.2, move the decimal. 15 doesn't go into 12, but it probably goes into 120 8 times. Is that the answer, 0.8? Huh?
Yeah, it's
You're supposed to
subtraction.
subtract
Addition.
What? So it's 0.5 into that, right? I'm convinced if I took these tests, I'd probably get a B on them. Anyway, so what's it end up being? What, 0.5 into 1.2 is 5 into 12? 2.4? Is that better? Did I get it wrong again? 2.4, sorry. Should have subtracted. So maybe I'd see if I were taking notes for myself on that, I would asterisk that and say, make sure you look to make sure you're adding. Don't make a silly mistake. Taylor.
Leave it number 12.
Number 11. Oh yes, one of my favorites. AX plus B equals C. How many people got this right? That's what I thought. Alright, here's the deal with this, children. The process of doing this with letters would be the exact same process you would do if it was numbers. For example, let me just throw some numbers in there. Let's say it was 5x plus 10 equals 15. The problem is, they're not like terms, so you're not going to be able to combine them, so you have to kind of get used to leaving them the way they are. If I was given this, what would be the first thing I would do? Taylor, right? Okay, so that's the same thing I need to do. I need to subtract b. But the problem is c and b are not like terms. So when you subtract b, the only thing you can do is put it next to the c and say, okay, it's c minus b. And now it's gone. Well, if I did that, I subtract my 10, I end up with a 5 over here. Now the next thing I would do is, how do I get rid of the 5 here? The thing in front of the a, I have to, Taylor? Divide by 5. Well, I don't have a 5, but I have an a. So I just take this whole thing and divide it by a. None of them are alike. You can't do anything more to it than that, and that is your answer. X equals c minus b all over a. Same processes, it's just that it doesn't work out nicely or combined. You just have to learn to live with it and deal with it like it is. With letters. Is anybody going to ask me about 13? Because I can already tell you if you missed 13. Anybody missed 13? Nobody missed 13? Oh, wait. When I look at this, what's the first thing I see and notice, Grace Watson? The thing that sticks in my head right away is that this is an inequality. There is a negative x. And when you see a negative x in an inequality, you're thinking, yes, darn it. Darn it, negative x. You're thinking that this sign in the end is going to be changed because your x can't be negative, and when you make it positive, it changes that sign. So you do the same thing as always. You subtract 3, and that doesn't change anything because I'm adding and subtracting. I get a negative x is less than 1. And here's where the darn it part comes in. I need to change this to its opposite. I need to change that to its opposite. I need to change that to its opposite. So x is greater than negative 1. And when you graph it at negative 1, open circle or closed? Open because it doesn't equal negative 1, and it shoots off in this direction. Fine, Connor?
Do you remember 11?
I don't want to. Wait, didn't I already do it now?
Yeah.
Oh. Sketch the graph, Ryan? This one is like a fun one to me. What form is that in?
Standard.
How do I solve standard form?
Cover it up.
So I cover up the x, y is? Cover up the y, x is?
3.
And your question on this is?
How do you get the other one?
What other one?
Do you get, like, doesn't that put the point at 3, too?
No. These are what we call the X and Y-Intercepts. Okay? When you cover up the y, right, you're looking for the place where the line crosses the x-axis. So the x-axis really is your other point. It crosses the x-axis at 3. You can put a dot there. So your y is 0, x is 3.
Okay.
Same thing with the other one. You are actually looking for intercepts. The only problem that comes in is when you end up with the origin being both of your intercepts, and then you gotta try to figure out what another point is. But this will always give you the 2 points. Kayleen,
I do number 19.
how do you? Yeah, I love you. Alright, so the first thing when I see this, I look at for addition and subtraction signs that aren't in parentheses. So that tells me I separate this problem into this part and into this part. And then I'm going to add those 2 parts together at the end, because order of operations say the last thing you do is adding and subtracting. This, what is a parenthesis around the -2? Nothing. Doesn't change anything. It's a -2. This one here gets a little more complicated. In order of operations, you have to do what first? Exponents and powers. So the first thing I have to do before I look at this negative in front, I have to take a -2 times a -2. -2 times a -2 is what? +4, but then there's still this negative that was out in front of that. That makes that a -4. And then your last step is you combine those. -2, 2 negatives, 4 more negatives gives me 6 negatives. -6. I love math. You too, David? There's no good answer for that. Alex?
14.
How many more do we have to do? Is that down here or up there? Up there? No, why did you tell me it was down here?
Yeah, let's
Convert 30 gallons per hour to quarts per minute using 2-unit multipliers. Show your work. Why 2? Because I'm changing gallons to quarts, and I'm changing hours to minutes. So you start off the same way. I have 30 gallons per what? 1 hour. I am going to multiply that by a conversion fraction. It doesn't matter which one, who'd asked me this question. Alex, do you want to change gallons to quarts first or hours to minutes first? It make no difference. Pick one. Quarts to gallons? So if gallons is on top, where does gallons have to be? So gallons have to be here, and quarts have to be here, and you need to know how many quarts are in a gallon. 4. So 4 goes up here, and 1 goes down there. I have now changed gallons into quarts. You can do the math if you want, it's 120, but we won't do that just yet. Now you need to change hours into minutes. So in order to do that, where does hours have to go? On top, so it cross cancels. And minutes have to go on bottom. How many minutes are in an hour? 60. So now I cross off my hours, and I just need to do the math. 30 times 4 divided by 60. Cross cancel if you like. 30 goes into 30 once, into 60 twice. 2 goes into 2 once, and 2 goes into 4 twice. You're left with just the 2 on top. And the labels you're left with are quarts per minute. 2 quarts per minute. Someday you will come back to me and tell me that unit multiplier / conversion fractions are one of the single most important things you've ever learned in math. The power of it is beyond recognition. Ava Ritkers.
I do 17.
17. 17. Yeah, that one always looks bad, doesn't it? Simplify that expression. Who got this right? I'm always. Cameron Atkins, what's the first thing you did? I'm going to rewrite it big over here. 4x. There are a bunch of ways you can go about this, and I'm not sure which way makes more sense in the 7th grade mind. Cameron, the first thing you did was?
Bring the negative y down.
Okay, get rid of the negative exponent, so you do that by moving it from top to the bottom. It becomes y to the positive 1, right? All right, and then what? Okay, so I'm guessing you said this. X to the fourth means you have 4 x's times themselves. And on top you have an x squared and this other x, so you've got 3 x's up there. Correct? Is that what you said? Oh. Maggie, did I do something wrong?
When you move it to the bottom, don't you add it?
Yeah, I haven't got to that part yet. I just left it down there. Yeah, you put these together, you get y cubed. Is that what you're saying? Yeah, sure. We'll put the y cubed down there, I don't care. Okay. But 3, you have 4 x's on top. There were 3 up there, so when you take those 3 away from those, you're left with 1 x on the bottom. And like Maggie said, I had y squared and a y. There's no y's on top, so I put those together and I get y cubed. There's no letters left on top because they've crossed off. And then last I have to do the numbers. 4 6 reduces down to, cut them both in half. You're left with a 2 on top and that 3 on the bottom. So you end up with a 2 over 3xy cubed. Somebody gonna ask me about 18? Yeah, let's do it while we're sitting there. Please remember, when you add or subtract like terms, they have to be exactly the same as far as the letters go. An x squared does not combine with an x. You get a little snooty. It's like the people that wear the Aeropostale shirts trying to get along, the people that wear the Under Armour stuff. So, if you have 3x squareds and you take 1x squared away, you're left with 2x squareds. If you have 2 x's and you take 1 x away, you're left with 2 x's minus an x is just 1 x. These two don't like each other, so they don't go together. And that's as much as you can do. Caleb.
Wouldn't it be a sec?
I'm sure it is. Just want to make sure you were watching. So that's 2 wrong I got on this test. What would that give me?
2 minus.
I'm still at an E minus. But I would have gone a lot more slowly. Ryan?
Number 8.
Number 8. Sometimes I feel like a broken record. Who can tell me the first thing I would tell you on this problem? Well, there's 2 things I would tell you. I guess it doesn't matter the order. Wait, did you ask me this question? Oh. Caleb, the first thing I would tell you is, when you see the word of, it is multiply. And then the second thing I would tell you is that if I'm multiplying 66 2/3%, and I'm multiplying that times $36, what am I going to tell you there? Because people will go, oh, I want to make 66 2/3% a decimal. Oh yeah, that's a good idea. That's 0.6 repeater. And now I'm going to say, that's a bad idea, because how do you multiply a repeater by anything? You can't. So, Alex, the second thing I would say is,
Change 66 2/3 to 2/3.
yeah, you must. If it's something, 33 1/3, 66 2/3, 0.4 repeater, any repeater, anything that ends up as a repeating decimal has to be changed to its fractional equivalent in order to do the problem. So this is just 2/3 times $36. 3 goes into 36 12 times, 2 times 12 is $24. If it would have been 50%, yes, 0.5 would work easily. 25%, 0.25, yes. But if it's a percent that changes to a repeating decimal, then you're in a world of work. Still, how many haven't we done? I found this to be rather exciting. What's that? K-Bron.
Can you do number 6?
16?
6.
10?
No, 6.
What is the area of trapezoid, whatever, F? Kabran, did you write down the formula for the area of a trapezoid? Is that a yes or no? Kabran, yes or no? Somebody, area of a trapezoid, no clausing? let's use the actual math base sub 1, base sub 2 type. And how do I know, Cabran, what the two b's are? Or not two b's? What are my two bases? And how do I know? In a trapezoid, the two b's are, somebody go once, or twice, huh? Yeah, but how do I know that? I was asking, that's what they are numerically, but how do I know in any trapezoid what the bases are? They are the ones that are, yeah, parallel. You're only talking about this trapezoid right here. And the two bases have to be the two lines that are parallel. And you did some math up there, and you got, well, the bottom is 20, and the top one was 6, I believe you said. Now what? So 1/2 of 20 plus 6 times the height, which has to form a right angle, which is this one right here, height of 12. Doesn't matter the order you do this, well, you want to probably do this first. 26 times 12 cut in half, or half of 12 is 6. 6 times 26 is what? 156? Is that right? That squared. Am I down to a B plus? Did I get that wrong? Did you get that right? Kala, am I right or am I wrong? Am I right or am I wrong? Still X2 B10. Load!
This is number 6.
6? 60. I'm glad somebody still finds humor in that. Not much. Logan, what should be the first thing you do there?
Added 1/3.
Yeah, add 1/3 to get rid of it on this side. What is 2/3 plus 1/3?
3/3.
Okay, which is what? 1. So 2/3 x equals 1. How do I get rid of a fraction in front of a letter? Julia? Anytime you saw getting rid of this fraction in front of a variable, you do what? Say who? Flip and multiply. So it is 2/3 times 3/2, and this is times 3/2. And what is 1 times 3/2? But, so if you had 1.5 or 1.5, that's fine. Just walk about that. Again, though, since the problem was given in fractional form, they'll give the answer in fractional form. Sometimes I feel you're just asking questions so that we end up with no time left. Cameron Atkins, what could we have left? Who? 17? There is no number 7. Down farther? Oh, yes, the little. Here we go again. You've got two letters there, the letter A and the letter N. What does the letter N stand for, Cameron? It's the number of the term, right? And A is the value of, I believe. You just take whatever the 12th term, the letter N should be 12. You just put 12 in for the letter N right here. Don't worry about that. It's the 12, the value of the 12th term is 12 squared minus 2. What is 12 squared? 144 minus 2 is 142. You're going to make me look and see what's left here.
20.
Which one?
20.
20.
20.
Do I have to do 20?
You can if you want.
I do want, by the way. Let's go ballistic here. Which one? Number 20. Where'd it go? 2 times the square root of 3 times the square root of 6 must be done how? Grace Watson?
That's 2 times the square root.
Right, you multiply your square roots together, so it's 2 times the square root of 18, and then what?
2 times the square root of 9 times 2.
Okay, this is the square root of 9 times the square root of 2, and then what?
And then square root of 9 is 3.
Yeah, 3 times 3 is 9, so that's your whole number that gets multiplied by that other whole number. So you end up with 6, and the square root of 2 just has to stay as it is.